In this example, we'll look at our final relationship between concentrations and pH by being able to look at pOH. So this example asks us, what is the pH of a solution containing 0.01 molar of NaOH? So first of all, since we have sodium hydroxide, we know that that's going to dissociate into the sodium cation and the hydroxide anion. And we know that there's one of those in sodium, so there's a 1-to-1 ratio of sodium hydroxide to the concentration of hydroxide ions. So we don't need to do any multiplication here or really any sense of stoichiometry. It makes it a much faster calculation. So therefore, concentration of OH minus is 0.01 molar as well. If there were 2 hydroxides, you would just multiply that given value by 2. If there were 3 hydroxides, you just multiply it by 3. So we have the concentration of hydroxide. We know that it's 0.01 molar, and we want to find pOH, and then we also want to find pH because that's what the question is asking for. So our first step is to use the pOH formula, which is very similar to pH. So it's pOH equals the negative log of the concentration of OH minus. So it's the negative log of 0.01 molar, or the negative of -2. And then, right, if you're subtracting a negative number, you subtract a negative integer, you're going to get a positive integer. So that means the pOH is 2. All right, so the pOH of this solution is 2. Now we need to look at the relationship between pH and pOH, which is pH plus pOH equals 14. So that's something that we always observe. So now we can manipulate that equation using algebra to determine pH. So logically, if we want pH, we just know that we're going to subtract pOH from both sides. And then we're going to get an equation that gives us pH equals 14 minus pOH. And then we know the pOH is 2. So the pH of the solution is 14 minus 2, which is 12. So therefore, the pH of the solution is 12. Another good way we can check these kind of questions to make sure that they're correct. The pH is 12, and then we know from the pH scale that pH values of greater than 7 are basic, and a pH of 12 is, it's very basic. So we also know that sodium hydroxide is a base, so it would make total sense that that sodium hydroxide would ionize in water to give you lots of hydroxide anions and therefore make a very basic solution. So the math works out, and then conceptually it also works out.